G'day, if you're looking for a way to really increase the microbial activity and populations in your soil, then a soil primer might be what you're looking for. So today in this video, we'll be going over what a soil primer is, how we use it in our consulting, how you can actually make up your own custom mix, as well as what we recommend, and its functions within say, a farming system. So to start off, a soil primer or the soil primer effect is actually more or less a studied thing. So it's not even just a kind of a regenerative term we throw around. It's an effect established in the literature. So effectively in the study here, you'll see that the soil priming effect is when you add new labile carbon to your soil, and it causes the rapid decomposition of old existing organic matter. And so it's interesting because typically you think, okay, if you add nitrogen, that will cause for the rapid breakdown of soil organic carbon. But it's actually not. It's labile carbon, which actually stimulates microbes to then go scavenge for nitrogen in that soil organic matter. So it increases the mineralization and the breakdown of the soil organic matter, increasing microbial activity. Now you might be thinking, do we actually really want to be breaking down soil organic matter for this? And it kind of depends. I think soil organic carbon or carbon within the soil is something that needs to be cycled. So it's not meant to be lost, but it's not meant to be maybe stored away forever. It's not an inert component within our soil. Our soil is living, and so is the soil organic matter. It needs to be cycling through, and you get that because of microbes. And so stimulating microbes is one of the best things you can do to actually build soil health because it drives so many functions within our soil. So let's talk about what is the result of the soil priming effect. Typically, you get an increase in microbial activity. This is really important and separate from what we'll talk about soon. But microbial activities range from a whole range of things. First one, nutrient cycling. So that's the microbes actually breaking down organic material or materials in our soil to release those. So it could be plant residue, animal residue, microbial biomass, anything organic, as well as the mineral component of our soil. So the total component. And this is something I'll show here. This is actually really interesting when you start looking at the total components of our soil. We get this done on our initial consult with our clients, and it sets a really good understanding of what is available within the soil. Now, sometimes if you've been managing really well in the past and you've been applying a lot of that nutrition, especially phosphorus, gets locked up. And so you might have 120 parts per million of phosphorus locked up in the total part of your soil. And then on the other hand, if you look at your available phosphorus, you might only have 20. Now the ideal in kind of a lighter soil might be around 30. So you've got all this phosphorus locked up in your total component of your soil, but actually not that much available. Now, this is where something like a soil primer would be really beneficial because you don't really need to apply any more phosphorus. You just need to unlock it, and you do that with microbes. So some microbes that release phosphorus solubilizing enzymes to take that the phosphorus in the total component into available for the plant. Likewise, microbes of fungi will assist with transporting that into the plant. So ideally with the soil primer, you'll get a bit of this phosphorus come down into that available phosphorus without needing to apply phosphorus because you've got all this stuff backed up in your reserves. Now, one really interesting thing to note, and I think it's quite important, is that sometimes you don't have this kind of system going on in your soil. You don't actually have that much total phosphorus. So I've looked at a lot of soil tests where we have both the total phosphorus as well as the available phosphorus. And there's not that much phosphorus in the soil just because the parent material itself doesn't have that much phosphorus. And so you can't make something out of nothing. And you need to make sure you actually have the phosphorus in your total component to supply your available phosphorus. There's a big train of thought in the regen space where if you simply have the biology, you will create the minerals. And that's not correct, or at least to my understanding, and I don't quite think that's scientifically correct either. You need to actually have the minerals. Now, it could be correct if you have these minerals in the subsoil. So say you have a texture contrast soil where you have sandy stuff on the top, clay stuff down the bottom, and you've got higher clay in your subsoil, then biology will help, especially larger organisms like earthworms or even your plant roots, bringing stuff from the subsoil up. That could be beneficial. But in terms of if you don't have total phosphorus, a lot of total phosphorus, you're not going to get available phosphorus. So that's a really big one. That's quite an important one. So that's nutrient cycling. The other activity that's quite important is increasing soil structure or aggregation or pore space which is important for a whole wide range of different things like infiltration, gas exchange, and this plays into the bigger idea of soil health. Lastly, another important component is a reduction in disease. So typically with diverse and active soil microbiomes, disease is likely to be reduced as you get increased competition and microbes prey on each other. You get a disease suppression effect within your soil. So they're the big things with the activity. Now, specific activities come from specific microbes. What we want to do is have a wide range of microbes to perform a wide range of activities and functions. So a soil priming effect can increase the diversity, or applying a soil primer can increase the diversity and finally increase biomass, which is quite important to store nutrients such as nitrates and ammonium from being leached away. It's also these microbes that can participate in the rhizophagy cycle, which then can feed our plants. So all of these things are important: increasing activity, increasing the diversity and the functionality of our microbes, and then the biomass, increasing biomass. So a soil primer itself is typically a liquid application that you'd spray and water in across your paddock. So ideally you want to get it applied typically before seeding or before the start of the active growing season. So for dormant plants like your orchards or even pastures, you want to apply this 2 to 3 weeks before seeding or the break of dormancy. And that will allow the soil and the microbes enough time to start mineralizing and carrying out these effects. Now you want to mix in your ingredients with as much water as possible that's feasible for your operation, and then apply that onto the soil. Ideally, just before a rain event to actually allow that those ingredients to then wash into the soil. So let's get into what would actually include in a soil primer mix. There's 2 components. There's a microbial component, which is the microbes we're going to add, as well as the biostimulants, which is more or less the food stock. So we want microbes as well as the food. We could just add the food, and that would feed all the microbes already within our soil. And we could also just add our microbes, and that would inoculate or add more diversity to our soil. But really, if we're going to make the application, we might as well just spend an extra little bit of money and apply both, and you get a synergistic effect between them. So from our microbial side, what we're looking for is a wide range of microbes to really inoculate and create as much diversity and functionality within our soils. So things like compost extracts, they're good. BAM, which is beneficial anaerobic microbes, they're good. They're good in particular because a lot of the times with our aerobic composts, you get aerobic microbes. Sometimes your soils are anaerobic. So there's a compaction layer, there's not much oxygen in it. So you want anaerobic microbes, or the beneficial anaerobic microbes, to then get into that compaction layer, and they can actually start breaking it up. So that's a really interesting one to use. Trichoderma, now that's a single species. And I'm pointing that out specifically because it might not be a bad idea if you're going to use a soil primer as a stubble digester. So that's another way of using it. You can put it onto bare soil to inoculate and improve the soil health, or you can apply it onto stubble, and it'll help to break down that stubble and to cycle it. Trichoderma is a really good one because it has great disease suppression effects. So you can apply it onto your stubble, break down that stubble, get rid of the disease load in it. And then finally, my favorite, worm casting extracts. Worm castings are by far, I think, the best option for inoculants, or a broad spectrum inoculants. Now, the gut of the worms are very diverse, and it has a whole range of unique microbes in it. So if you'd like to see a fantastic review on worm castings, or the fancy way of saying is vermiculture extracts, then you can check out the effects of vermicompost on soil and plant health and promoting sustainable agriculture. In that, you'll see everything you need to know about the benefits of worm castings and worm casting extracts, and basically just goes through all the different functions, a bunch of different studies. But really, worm castings contain a whole wide range of microbes that can do majority of the functions you're seeking for in a soil primer. You can go to individual species, but I really think the broad spectrum approach is the best way because we simply don't know what the role of every single microbe does. And so it's better to apply them all, take a bit of a shotgun approach, get them all in there rather than trying to focus on picking the right ones. Or at least that's my approach. Unless you really know what you're trying to target, like the trichoderma, then it's worthwhile doing. Now, a good thing to note, you won't see mycorrhizal fungi here because mycorrhizal fungi actually colonize the root of a plant. So if you're applying this and it's just coming after a fallow period, there's no plants there for the mycorrhizal fungi to colonize. So you're basically just wasting money. What you want to do with mycorrhizal fungi is apply as a seed coat, and that's really it. There's no point in doing it in a soil primer, or at least I haven't seen it. This is really for microbes that are decomposers, or they prey on other microbes. So now onto the biostimulants. You'll notice here we have a range of different things. Now, this is not all of them, there's others, but these are typically what I focus on. These contain carbon and highly labile carbon, which means they can act as food source for our microbes. Now, typically a simple carbon source is going to stimulate bacteria, and a complex carbohydrate or carbon source will stimulate fungi. And so the biostimulants really have two effects. They have an effect directly on soil as well as the direct on our microbes. And really the aim of the biostimulant is to boost these microbes, the microbes we're actually going to apply, as well as the microbes already within our soil through this soil priming effect. So in one of the studies, molasses increased a range of microbial enzymes in the soil. And so the thing with molasses is that it acts as a really good source of carbon. It's also really cheap too. So in the study, I think they found that it was the ideal application rate was about 10 litres per hectare, with a toxicity effect at about 400 litres per hectare. So you don't really want to go past 400 litres per hectare, and I'm pretty sure the cost of it's about $1 a litre. So $400 per hectare, probably wouldn't, but $10, and that's $10 a hectare is not bad. That's pretty good for molasses. Another application. Next is humic acid. Now this serves a bit more of a fungal food because it's a bit more complex. It's one of our humic substances. This is quite beneficial on sandy soils. So really great way of increasing the cation exchange capacity of the sandy soil and making everything stick to it. So you can apply humic acid at 5 litres per hectare. It's not a bad one. Now humic acid probably has one of the biggest benefits you can get from any of the biostimulants. So you can see in this study here, basically humic acid improves everything in the soil. It improves the physical, chemical, and biological functions within the soil. And it's a great way of really improving your soil health from effectively a product application. Likewise with fulvic acid you can also apply at 5 litres per hectare as a full rate. And that basically does the same. It simulates more the bacteria side of things, which is more cycling or faster turnover. And that can be really beneficial if you're starting from a highly degraded soil and you just want to stimulate biology. It doesn't necessarily matter the fungi to bacteria ratio. In a system where you're initially starting off, it's just important to increase microbial biomass rather than a bacteria to fungi ratio. Kelp's a great one. It has quite complex carbohydrates in it. I think this one here you can also apply this somewhere between 1 to 5 litres per hectare. Now all of this, if you mix it together, you're going to reduce your application rates. We're going to go through over an example of that later. And I think the combination of everything really makes a synergistic stack. So with kelp, you can see it in this study here. There's a whole wide range of effects too, or beneficial. And then finally with fish. Now fish is a good one. There's a high amount of nitrogen in it, which can be quite beneficial just in small amounts in terms of this overall stimulating microbes. Ideally, we want to be targeting the carbon component, but fish can also be quite beneficial, and you can see it in the study here. This is more looking at amino acid or protein hydrolysates, and you'd get fish as a hydrolysate as well, but that stimulates microbes and can improve soil health too. Now, finally, I have minerals. Now, sometimes it can be quite beneficial to include soil applied minerals in your soil priming because you're getting it out there in a liquid application, which is very uniform. So if you're applying things like molybdenum or cobalt or selenium, all those things where you only need, like with molybdenum for example, you only need to be applying 35 grams per hectare. So you can mix that in to your soil primer, apply it across your paddock, and you get a really uniform distribution rather than trying to get 35 grams, which is a tablespoon, and sprinkling it across your paddock. But yeah, that's a really good way. This is a really good way to apply a lot of those trace minerals where you don't need that much of. Likewise, zinc. I wouldn't do copper because copper can be a biocide. So it does depend on what you're trying to apply. And if you are going to include minerals, make sure it's not going to kill your biology, because this is really just trying to target biology but adding those minerals to it can be quite beneficial too. Okay, so finally, I'm going to give you 2 recipes, a DIY one and what we kind of recommend to our clients. So in the DIY mix, what we're going to do is we're going to have at the base of the mix 10 litres, and this is all per hectare. So we're applying this per hectare. We're going to dilute it all down, maybe between 50 to 200 units of water to 1 part of this. It really depends. But really, you want to get your application or your water rates as high as possible so you can really soak in. But anyways, 10 litres of molasses. Now this is optional, but I would suggest it regardless of the soil type. If you're in a really sandy soil, it's almost a must. Other ones, not so much. So we're going to apply 5 litres per hectare of humic acid. Next, we're going to apply 1.5 litres, so not as much, of fish hydrolysate. Next, we're going to apply 1.5 litres of fulvic acid. And then finally, we're going to apply 1.5 litres of kelp, liquid kelp product. Now, when you're doing this, make sure the pHs work out, because otherwise you're going to get a reaction in the tank, and you don't want that. So make sure you do a jar test first and make sure all works together. You don't want a slurry, you want a liquid application. So this here, these make up our biostimulant side of things. You can add your minerals if you want, but this is kind of the stock. What we would recommend is a worm casting extract. So we're going to apply 5 litres or whatever the suggested application rate of water in application of your worm castings. So you can add all that in, you can make it yourself, doesn't necessarily matter, but all of this, mix up and tank, apply it per hectare. And it's suggested that $100 a hectare you make back from the increase in nutrient cycling and improved soil structure and a reduction in disease. It can be difficult to quantify some of this, and so perhaps just doing 1 paddock at a time to quantify the effects for yourself, measuring the yield or the infiltration rates, or even comparing the soil tests year on year after an application like this. Now, what we do in our recommendations is we use product suppliers to just make all this easier. So the first one we use in our program, which you can see it on our websites. We have all this written up on our website. You can get the products on our website. The first one, which is Microfeast. So Microfeast is more or less the fish fulvic kelp part of this, as well as a whole bunch of amino acids and carbohydrates. So it's a little bit more complex than this. It's formulated to be a bit better than the DIY component. But anyways, we're going to apply this at the 5 litres per hectare. What we're going to include with this is MicroStart at 5 litres per hectare, which is a worm casting extract. Now you could probably get away with just these 2 things. So rather than trying to source all this yourself, you can just work with us. We can supply that. 10 litres, you bulk that up a bit more, and then you can apply that. In addition to this, because it's so cheap, I'd recommend putting in 100 litres per hectare of molasses. It's so easy, and you get just that extra bit of labile carbon. And then finally, if you're on that sandy soil, getting a bit of the 5 litres of humic acid. A very last thing that you might want to consider is actually adding a bit of liquid calcium. So this really depends on your calcium levels, but the liquid calcium has been found to stimulate biology and bind to soil organic carbon to improve it that way and preserve it. So if you're going to do this, a micronized version, if you have a good mixer in your spray unit. Otherwise, I'm sure you can get other sources of a liquid calcium product, maybe like a calcium acetate or something like that. But you'd want to apply that at 20 or so litres a hectare. So this in itself adds a lot of cost to the overall mix, but these components, they'll add up to about $100 per hectare. So it can go towards your general fertility program. Some people talk about this as being basically a cover crop program within a jug, just without the cover crop component. Now it's a similar idea in terms of the effect that we're having on microbes and the function within our soil. I don't think you can completely replace cover crops, but if you're going from a system where you can't quite integrate cover crops and you really want to stimulate biology, this is a great way to do it. for more or less maybe the same price. Like I said, you can put this on 2 to 3 weeks before sowing, and it should improve the efficiencies of all your other systems. So if doing something like this is of interest to you and you like to try it on your own farm, make sure to reach out to Agresol. We can help you out with a free regenerative consultation. Likewise, we offer our consulting programs and hope you get started. Awesome. Thanks again for watching. My name's Teal. Cheers.